In this video, we will learn about the types of chemical reactions. First type of reaction is combination reaction. In this reaction, A and B on the left side are the reactants, and AB on the right side is the product. In this reaction, there are two reactants which produce a single product, AB. Such type of reactions are called combination reaction. In combination reactions, there can be two or more reactants. Let's say A, B, and C. There are three reactants and they react to produce a single product A, B, C. Such reactions are called combination reaction. For example, hydrogen gas and oxygen gas reacts to produce water. In this reaction, hydrogen and oxygen are the reactants, but H2O, that is water, is the product. So this is an example of combination reaction. Our next reaction is decomposition reaction. The reaction in which a single reactant reacts to produce two or more products. It is the opposite of the combination reaction. In combination reaction, there were two reactants and product was only one. But in the decomposition reaction, there are only one reactant which reacts to produce two or more products. That reaction is called decomposition reaction. There are many types of decomposition reaction. So first one is thermal decomposition. What is thermal decomposition? The decomposition reaction which takes place under influence of heat. Let us assume a compound AB. Let us assume a compound AB, and after heating it, it decomposes to A and B. That means in this process, heat is required to decompose the AB compound into A and B. That type of decomposition reaction is called thermal decomposition, in which heat is needed. For example, when we heat lead nitrate crystals, that is PbNO3, 2, then it decomposes to lead oxide and nitrogen dioxide and oxygen gas. In this reaction, a brown color fume evolves, which is nitrogen dioxide. So the reactions in which heat is essential to decompose any reactant, that type of reaction is called thermal decomposition. Second type of decomposition reaction is photolytic decomposition. What is photolytic decomposition? The decomposition which needs sunlight to decompose. Let's say AB is a compound and we expose AB in sunlight. Then it will decompose to A and B. Let's say, for example, when we expose silver chloride AgCl in sunlight, then it decomposes to silver and chlorine gas. So color of silver chloride is white, but the color of silver is gray. So in this reaction, change in color is taking place, and this reaction needs sunlight to decompose. This is the example of photolytic decomposition. If we write the definition, the reaction in which sunlight is needed. If we take another example, say silver bromide AgPr. Again, if we expose this in sunlight, then it decomposes to silver and bromine. So if we balance the reactions, then this will be the balanced chemical equation. And again, this will be the balanced chemical equation for this reaction. Now, if we see these two reactions, silver chloride and silver bromide, these two reactions are used in black and white photographies. Another decomposition is for electrolytic decomposition. In electrolytic decomposition, electricity is needed to decompose. For example, when electricity is passed through water, then water molecule breaks down into hydrogen and oxygen. So in this reaction, electricity is essential. So when we pass electricity through water, then it decomposes to hydrogen and oxygen molecules. This is the electrolytic decomposition. Number three types of chemical reaction is displacement reaction. So what is displacement reaction? The reaction in which a high reactive element displaces a low reactive element from its compound. In this reaction, let's say A is high reactive, then B. So if we see the reactivity series from top to bottom, reactivity of elements decreases. So the high reactive elements are potassium, sodium, calcium. When we go down, the reactivity of the elements decreases. So in reactivity series, potassium is the high reactive element and the gold is the low reactive element. So let's say in this reaction, let A is the high reactive element and in this compound BC, let B be the low reactive element. Then what happens in this reaction A, which is high reactive, it displays B from its compound, that is BC. So A is displacing B, that means B will be removed and in place of B, A will be added. That means it will form AC and V. In this reaction, A is high reactive and B is low reactive, and A displaces B from its compound BC. This type of reaction is called displacement reaction. Uh, for example, when iron nail is dipped in copper sulfate solution, CuSO4, whose color is blue, color of copper sulfate is blue. When iron or iron nail is dipped in copper sulfate solution, in this reaction, see iron is more reactive than copper. So in this reaction, iron is more reactive than copper. That means this is our high reactive element, this is low reactive element. So iron will displace copper from its compound copper sulfate and it will form FeSO4, iron sulfate solution, and copper will be displaced. And the color of iron sulfate is light blue or approximately colorless. That's why when we dip iron in copper sulfate solution, this solution's color, which was blue, turns into light blue or colorless. So this type of reaction is called displacement reaction. Now see what is double displacement reaction, the reaction in which exchange of ions takes place. Let's say a compound AB which is reacting with another compound CD. In this compound, let's say A has the positive ion and B has the negative ion. And in C, let's say B has the positive ion and D has the negative ion. So basically in this, what will happen in this reaction? They will exchange their ions with each other. So A will give its B ion to C and C will give its D ion to A. They basically exchanging their negative ions. So it will form when D comes to A, it will become AD and this will become CB. This type of reactions are called double displacement reaction. For example, when barium chloride BaCl2 reacts with sodium sulfate Na2SO4. See, in this reaction, barium has the positive ion and chlorine has negative ion. And again in sodium has the positive ion and sulfate has the negative ion. So basically they will exchange their ions. That means barium will take the sulfate ion and sodium will take the chlorine ion, then it will become sodium chloride NaCl plus barium sulfate BnSO4. So in this reaction, when barium chloride reacts with sodium sulfate, a white color precipitate is formed, which is barium sulfate, and it is insoluble in water. Color of barium sulfate is white. And if we take another example, when lead nitrate, which is PbNO3 2, reacts with potassium iodide, that means Ki, they exchange their ions, that means lead iodide will be formed, and also potassium nitrate will be formed. That means they basically exchange their ions. Lead has the positive ion and nitrate has the negative ion. In potassium iodide, potassium has the positive ion and iodine has the negative ion. So they exchange their ions and produces lead iodide and potassium nitrate. In this reaction, a yellow color precipitate is formed. So color of lead iodide is yellow and it forms precipitate in this reaction.